North Atlantic Ocean. Beneath the surface of this dark and cold ocean exists a thriving ecosystem of fish, invertebrates, seals, and whales. This wealth of marine life can only exist in such numbers because there is plenty of food for all these animals to eat. The food web that supports these animals begins with plankton. The word plankton comes from the Greek, meaning drifter. So technically anything that drifts with the currents of the ocean is planktonic. Usually plankton are small, like these tiny copepods. But some plankton are large, like this jellyfish. There are two basic kinds of plankton, phytoplankton and zooplankton. Phytoplankton means plant plankton and includes all kinds of drifting plants like microscopic diatoms and algae. These tiny plants might not seem very important, but they're probably the most important part of the ocean food web. When given the right conditions of sunlight and nutrients, these tiny plants grow and multiply, turning the water green from their chlorophyll and becoming food for the other kind of plankton, the zooplankton. Zooplankton are animal plankton. The most common kind of zooplankton is the copepod. A copepod is a tiny crustacean, seen here compared to a grain of rice. It would take about 250,000 copepods to fill a coffee cup. These are the most numerous animals on Earth, populating the oceans around the globe. They are even more numerous than insects. There are other kinds of zooplankton too, from the sea butterfly to jellyfish. This jellyfish is called a lion's mane. It can reach 100 feet from the top of the bell to the bottom of the dangerous venomous tentacles, proving that not all plankton are tiny. All these zooplankton are food for larger animals in the ocean. The basket star uses its tiny arms to capture plankton from the water. Anemones capture plankton with venomous tentacles. Scallops filter plankton from the water internally. Squid eat small fish that eat plankton, and even the mighty humpback whale dines on small fish that eat plankton. Higher on the food chain, sharks eat fish that eat smaller fish that eat plankton. Without zooplankton, small fish would starve, and without them, the larger fish would starve. So nearly everything in the ocean somehow depends on the zooplankton. But the zooplankton eat the phytoplankton. So ultimately, it's drifting phytoplankton that keeps the entire ecosystem in the ocean going. But what keeps the phytoplankton going? Phytoplankton are just plants, and like all other plants, need two basic ingredients to thrive: sunlight and nutrients. Sunlight can vary in the ocean. Down deep, sunlight is very dim or absent, so phytoplankton can only grow near the surface. But generally, phytoplankton growth is limited by nutrients. If there are no nutrients in the water, phytoplankton have nothing to convert into tissue. To understand why nutrients are limited in the ocean, we have to look at where they come from. There is always a small supply of nutrients getting into the ocean from runoff. Nutrients in soil get washed into rivers, which then carry them to the sea. But this small amount of nutrients can't possibly be enough to keep all the phytoplankton in the oceans growing. Most of the nutrients in the ocean come from other animals and plants that have died and decomposed. When plankton and other animals and plants die, they sink as they decompose. A constant rain of marine snow slowly carries nutrients down beyond the realm of sunlight. Down in the ocean depths, lots of nutrients are available for the phytoplankton, But without sunlight, they can't grow. For the phytoplankton to use the nutrients must be transported to the surface. During the summer, the sun warms the surface layer of the ocean. But a few hundred feet down below, the water is icy cold. The warm surface water floats on top of the cold, dense deep water like oil floating on vinegar in salad dressing. The barrier between the two layers, called the thermocline, keeps the nutrients down below. In the winter, the surface water gets cold and the thermocline disappears. Now the nutrients can get to the surface. Winter storms help by churning the ocean with big waves, bringing the nutrients to the surface. By the end of winter, there are a lot of nutrients in the surface water. When spring arrives, the days get longer and the phytoplankton start to multiply, bolstered by ample nutrients and sunlight. This is called the spring bloom. The bloom in phytoplankton means that the zooplankton now have a lot to eat, so they multiply. Suddenly, the ocean becomes a rich planktonic soup filled with food. Many other animals come to the higher latitudes to feed during the spring when the plankton is blooming. One of the most well-known animals that comes to feed are the whales. This right whale can eat thousands of pounds of copepods every day. It has an enormous appetite and needs vast quantities of plankton. It has no teeth, but eats by straining plankton from the water with a special filter in its mouth. As summer goes on, the surface gets warm and the thermocline develops. Slowly, the supply of nutrients is cut off and runs out. Then the phytoplankton slow their growth and begin to die, sinking towards the bottom as marine snow, where they will form new nutrients and start the cycle over again. The North Atlantic Ocean has the largest plankton bloom in the world every spring. In fact, the change in water color due to the plankton bloom can be seen by NASA's satellites. In this false color image shot in winter, areas of high biological productivity are seen in red and orange, while areas of lower productivity are seen in blue and purple. As spring gets underway, the plankton bloom can be seen in the northern waters. During summer, the bloom dies off as the supply of nutrients becomes limited. And in fall, there is another smaller bloom as the nutrients become available once again. It's interesting to note that the southern tropical waters seem to have much less plankton than the cooler northern waters. Many people mistakenly believe that because there's a lot of sunlight in the tropics, there's also a lot of plankton. In fact, the tropics have very low amounts of plankton. This is the reason why tropical water is so clear. Because the tropics have warm surface water even in the winter, the thermocline never goes away, and the nutrients stay trapped down below in the depths. So even with ample sunlight, phytoplankton growth is severely limited. In the tropics, predators like coral make good use of what little plankton there is. Plankton may be one of the most important kinds of organisms in the ocean. Tiny phytoplankton has been estimated to produce more than half of the oxygen we breathe, and it feeds great swarms of copepods, the most abundant animals on Earth. In turn, these copepods and other zooplankton feed fish, invertebrates, and even whales. Without plankton, nothing could survive in the ocean. It is important that we do not introduce pollution into the oceans that may harm the production of plankton. If plankton were unable to grow for some reason, all life in the oceans would suffer as a result. Sometimes it's hard to imagine that something so small and seemingly insignificant could be so important. But by understanding some of the ways that nature works, we can realize the significance of something like plankton. Yet, As we continue to explore the oceans and the ecosystems that thrive there, we continue to learn how little we actually know.